Hello, I'm Jade, the marketing specialist here at GTS. We've been growing as a company and have started to dip our toes into the AI world. Today, let's discuss what generative AI or Gen AI is with OmniAGI's AI and data team and resident expert, Dr. Atif Mohammad. Dr. Atif has a PhD in cybersecurity and his second PhD is in scientific computing. Dr. Atif is the Chief AI and Data Officer. All right, so let's just get started. What is generative AI and how does it differ from other AI approaches?
Well, thank you so much, Jade. It is always great to have Ram, Jess, Sean, and Brian alongside you. Generative AI is an extension to artificial intelligence and deep learning combination. It generates results which are non-human uh, comprehension. That's what I say. However, the results are showed for a human to comprehend in a standard subject, verb, object ways. So the generative AI is to generate the meanings of something that as a human we can understand within our context. So if we are if we are pardonnez-moi in French or pardon me in English, if we are on a vacation and we are having fun, we have a 3D look out with our eyes because we can look in the front and we can look on these sides, so I can easily figure out that this side is wall and this side is an open space. And because I'm showing you with my hands, so you can comprehend by the visuals how this is. What if there's a person who's blind and needs to give the explanation, and we have to explain, I'm having my right hand pointing right side and my left hand pointing left side. This is a generation of a scene for an individual to comprehend who's blind or who cannot see. Can we do that in the dark? Yes, we can as a human, because we have an absolute understanding of our context. Generative AI creates a pre-context, context, and post-context of a situation for a human to comprehend on the basis of the available data that has been given to it, as ChatGPT is an example, that is generative pre-trained transformers. Hopefully, this is a verbose answer that I shared. I would like to request Brian to elaborate on his experience, because Brian has been working with me in the area of generative AI for a while. Him and Sean.
Yes, so thank you, Dr. Atif. That was a very good verbose explanation. For those of us that live on a little more on the street than Dr. Atif, I think, Jade. Really, the important part is that it feels like it can carry on a conversation with you because of how it's generating its responses. But the model itself actually has no concept of the words or even the language or even visually, if it's something like stable diffusion, making images based on words. It's really putting together stuff that it's been trained on. And a lot of this training takes a lot of time and a lot of computing power, getting to the point where it's a significant amount even compared to the other large compute sync nowadays, the last couple of years, Bitcoin, right? It's the same depth of computation required to generate this value that we're getting. But the value helps us analyze and helps us deal with things that sometimes take us too long. We're always skimming through things and maybe missing details in the document as we're looking, or we forget one thing. The generative AI can very quickly determine something's missing that may be significant based on the content it was trained on, and it can raise your awareness on that. Kind of like my wife likes to do when I'm driving at night, and reminds me that I need to stay awake behind the wheel of the car, right? Generative AI can allow us to do those kinds of things that not that we get lazy, but as Dr. Atif said, the way we conceptualize and the way we use multiple cues, sometimes we have a fatigue of trying to get those details. And it doesn't become easier using a spreadsheet to add numbers when you're fatigued because of the meaning of the numbers, whereas a generative AI can sort the numbers and maybe give you some graphs that allow you to navigate it. differently, right? So that's where I think the practicality comes from, this interesting approach to our knowledge we've collected, separate from human comprehension.
Okay, wow. That's
Yeah.
super interesting. So the next question is, can you give an example of a real world application where generative AI is being used?
My personal favorite use of generative intelligence, and in this context, is code generation. So when I started looking at large language models that can produce code, I started with one of the bigger models, which is Bloom. Bloom was trained in the, in line with the French government. It was trained on a nuclear-powered supercomputer. And ironically, it's been said that perhaps the training of that model was not completed, which is why perhaps there are some performance issues with Bloom, but that's another story. What I'm very interested in is being able to make developers more productive. In computer science, there's this idea that you shouldn't have to solve a problem more than once. Once it's solved, you can move on to more challenging problems. So I'm very excited at the use of generative artificial intelligence in making software organizations more independent, more productive, and able to produce more products and services for consumers at lower prices. There's a fear that perhaps some software developers have that generative AI is going to, take their jobs or displace them. But I really believe that generative AI is actually going to make the developer more productive in many ways. So teams will be leaner, they will be more efficient, but they're also going to be a lot more productive. And this is going to facilitate smaller organizations to be able to compete with larger organizations with a smaller footprint. So efficiency is the name of the game here.
Right. So, and thank you, Dr. Atif, and thanks everyone. Right. So I'm very new to generative AI. Right. My knowledge starts obviously with after conversing with Dr. Atif and Bryan and Sean. I have learned a lot. Right, in the past few weeks and months. Now, I'll touch on the use. Right. How is it helping generative AI? Helping folks like us, right, where efficiency is the utmost important as well as quality. Obviously, not blindly following what you get output from GenAI, but you be your judge. It's like I treat GenAI as my personal assistant who can guide me but doesn't dictate for me, right? I take the answers and see if it fits, and then and go back out, right? So what we are trying to do. We are trying to build out a really, really smart widget, which was not possible prior to GenAI. When I say not possible, you don't get the free flow of info that GenAI will give you, rather than it was more of someone has to sit there and analyze what questions were asked and what answers was provided. Someone has to go fine tune those, right? It's a lot of manual work. Now, with our smart widget, what we are able to do is we are able to talk to the large language model sitting behind to generate responses. From those responses, right? Because we as a human, we like to see the data presented to us in a well-defined and aesthetic point, from the aesthetic point of view, much more cleaner, right? Otherwise, our attention span will just move away. So what we have been trying to do is, with our chat widget, the smart widget we call, is we are able to take the data from GenAI response and present it in a nice format. Like if there's a video feed that GenAI came back saying, here's the URL of a YouTube video, right? We have two ways to present that. Either we just post the link back onto the widget, or we actually show the YouTube video on your widget. Naturally, we are going to click on the widget and watch it, right? Rather than opening, copying it, and putting it in the browser, right? Same thing goes for the images and other form of media that can be embedded. On top of that, we now have more flexibility. We can analyze the video feed from all this widget. For example, healthcare. If we want to give more insight to the doctors or the healthcare provider from a video feed saying this is what we think is happening, right? We just show our hand. There's a cut on our hand. That image or the video can be processed through the LLM, right? And presented, the insight can be presented back to the healthcare provider saying, looks like this is what's going on with the person, and this is the recommendation from the LLM, right? And the doctor can look at it, doctor can advise, either take it blindly or analyze that and present back to the user, right? So the smart widget has a ton of use in the contact centers, in healthcare, in education, and any industries you pick, right? Use cases wise, and I think it's one of the smartest widget that we have created. Takes care of the video, audio, any type of media, signature, right? We're in the healthcare domain, and the agent wants you to sign a piece of paper. How do you do that? Today in the world, they send out an email with DocuSign or some kind of form. You go ahead and sign it. It takes time. With our widget, that we can push out a signature pad right to the customer. They can sign it on the widget so that it gets captured, right? So we have not named it yet. I think we named that's Bryan came up with a very good name, MIE. For the smart widget, and hopefully we're going to show it on our fireside chat next week.
Wow. Okay. So it sounds like this is some really powerful stuff. What are the main advantages of generative AI in comparison to traditional AI models?
So let me put a little light on that. The traditional artificial intelligence is pretty straightforward, direct. You either apply supervised learning, semi-supervised learning, or deep learning or unsupervised learning, and these are all machine learning's forms. And you give a certain set of data, feature extraction happens, the data munging happens, and then feature extrapolation happens in terms of probability and in terms of the prediction, which allows an artificially intelligent agent to produce some results on massive amounts of data where human cannot actually go and work. And there are tons of humans are needed to work with that. Whereas generative artificial intelligence takes and works with the plausibility. So there is a significant difference between a probability and a plausibility. If you don't know that, I'll not bore you with the details. The plausibility is something that whether the probabilistic thing should be taken or whether it should be taken some plausible prediction. And a standard prediction, which is probability, lies between 0 and 1. Whereas plausibility actually allows us to expand and give more than 2, 3, 4 options to look into a detail. Let me give an example. If you leave your laptop open in a home and the laptop camera is open, and right in front of the laptop, there is a dog sitting, a real dog and a fluffy dog. And when you come home, you see that everything is on the floor messed up. Now, would you blame the fluffy dog or your dog? You know your dog is fantastic. And then that camera has captured some of the messed around thing which is happening in the room. Now, the probability is that this is your dog who messed up. But you figured out with the voices which are not dogs' voices, rather dogs' barking voices. And when you look at as a human, you found out that a little bit of window was open and potentially a squirrel came in and messed up, and dog was trying to catch. That's why dog was running off and on the camera. That's a human understanding. And if we want to go and put it in LLM, that entire story where there's never a squirrel in front of the camera, but there are audio pointers that came in. So you will figure that out, that either it's your dog or some squirrel or somebody who was in your apartment who never showed up on the camera, whereas your fluffy dog was always there in front of the camera. So the idea is LLM can take several stories at one time and compute them, process them, and give you some plausible results, whereas probability will be stuck with between 0 and 1. Plausibility will give you more answers. I understand this might not be your regular answer, Jade.
Hmm.
This was the best human comprehension that I could share with you, that human processing and the LLM processing or the GPT processing. Back to you.
And I want to kind of contextualize a little bit here, Jade. That was, very similar to what we were talking about earlier. For narrow AI, we would have had to train a camera to detect what was going on, and it would detect dogs. It would completely fail and say unknown movement, even if the squirrel was on the camera, right? And so the narrow AI would be able to tell us what's happening potentially, but it wouldn't be able to identify stuff. We'd have to go through, and it could highlight things that we needed to look at. Maybe, this section has unknown sounds. Whereas a large language generative model, we could say, what could possibly have caused this type of mess? And the large language model could give you a list of, a window could be open and a large gust of wind could have done it, right? And so the model is, for us, it's almost like a free get out of jail pass if you have writer's block as a writer, right? So using it to help us, blue sky things. I have a friend who really likes cars and really likes sports. What would be a good gift for them? And an LLM could generate 8 items, some of which are probably not a very good gift, but it would help you think about possibilities too, right? So that generative, it can totally draw conclusions that aren't part of the original question. Whereas narrow AI that we've had until now, we'd have to, like if we're doing tables of data, we'd have to put it in a database as columns, and then we'd have to query it with a database query language to ask it a question. Whereas an LLM, we could say, are there any features besides, age and first name that are similar in this table of data? And the LLM could generate a diagram or even a summary, right? Where you wouldn't be able to do that with narrow AI because we only wrote it to answer a question that you've specifically asked it with data that looks exactly like you told it to return, right?
I would like to add a little bit, Sean and Jade. Yeah, that's exactly right. So the distinction between focused or narrow AI, okay, which would be your traditional machine learning or deep learning models, are trained on data to identify either a class of object, discriminate between one object versus another object, or categorize things or cluster things. It's really good once it's trained and the model converges. It's really good at identifying specific things which it's learned. Now, large language models, they bring generalizations, meaning that these models can perform quite acceptably well on things that they have not been specifically trained for. So that's sort of one step closer to getting us towards generalized artificial intelligence that can, given a problem statement, can look for solutions and find novel ways to solve those problems.
Okay, yeah, that makes sense. Thank you guys for clarifying that. Are there any limitations or challenges associated with generative AI that we should be aware of?
Absolutely. Deep fake is number one. The Samsung employees using ChatGPT and all the information being leaked out is number two. The privacy. The other thing, yesterday, I have heard a friend of mine called me from New York, that what exactly is happening in DC. And obviously, I was unaware of anything. There was a chat GPT or something like that created a havoc, And quite a few news agencies picked on that and depicted that there has been an attack at Pentagon, which was absolutely deep fake. Nothing was happening. All the index funds had a dive. So that's technically a direct impact on our business, on our industrial investments and all that. Yeah, that's one example. The other example is we need to be careful by running the private LLMs. And I would request Ram to shed some light on that, because private LLMs at GTS and OmniAGI, which is working at this very moment in 3 different parallels, will be helping organizations to have PII controlled, PHI controlled, HIPAA controlled, FERPA controlled. And if you don't know these words, find it out on Google. And these are all security things. My cybersecurity training kicks in immediately to do the threat detection or threat intelligence. And LLM, in terms of private LLM, is the most secured way, and we do have those in our arsenal at GTS and OmniAGI. Ram, over to you. Thank you.
No, thanks a lot. So that's a great point, right? What we have seen in the past, as Dr. Atif mentioned, Samsung and other, right? This big public LLMs, they are not. No one knows what they do with the data. You don't have access to any inner workings of the public LLMs, right? Especially, I always advise everyone to stay away from ChatGPT if you are going to put in a sensitive info and try to get an answer. Don't do that, because that data is exposed. They will use that data and use it to train their model. That means it's a public data. If you're putting any proprietary stuff or confidential, those won't be confidential anymore, right? With the public, with the private LLM, since we do a lot of work with the state and local government, right? And their data cannot be exposed outside. Even if you are trying to get enterprise agreement, right? There's always a chance that data will make it, because they're not going to share how they're going to use your data, right? They might have all the encryption and everything in place, but still you are not in control of your data, right? With the private LLM, what we're saying is the state and local government or the agencies or anyone, healthcare, financial, if they want to just keep it private, no one else has access to it, they will be able to train the private LLM that sits in their environment, right? Their premise, on-premise, if they have a secure cloud environment, those can run in their under their security and can be trained on the data that they have access to. They can retrain, they can drop the old data, retrain with the new data. They have the flexibility of maintaining their LLM, right, on their data. So that's what in GTS we have been working on, building out this private LLMs, greener, right, have tighter security control, and can be trained as new data comes in.
And that's exactly what guardrails come in. Brian,
Right.
would you like to shed some light on this?
Yes, absolutely. So guardrails are extraordinarily important, especially with generative AI systems. As you can imagine, if you have customers or if you have a call center solution or a chatbot solution that integrates large language models, you want to be very cautious that the model is not saying inappropriate information, making disparaging remarks, or somehow being tricked into revealing information that it should not be. So having guardrails built into the application that control things that are the equivalent of SQL injection, where tokens can be inserted into the conversation so that the large language model is manipulated into displaying information or making statements that go outside of the guardrails. So there's a lot of things to consider when having a public-facing large language model interacting with your customers and with your data. So having a knowledgeable team that understands the risks associated with these models and is able to put in place protections and just has a strategy of addressing these issues is very, very important.
And given the cybersecurity degree that Dr. Teef has and our experience with security at OmniAGI, this is a very dangerous mix, the two things that we just talked about here. One being the trustworthiness of the data, right, and the source of the data. If I train a model on, all of the episodes of Friends, and then I ask the model to be a psychiatrist and give me an assessment of somebody's mental state, it's going to come up with completely legitimate sounding, completely fake diagnoses, right? And in the wrong hands, it's just like the internet, WebMD. In the wrong hands, you have people diagnosing all sorts of crazy things without an expert grounded in human intelligence to say, wait a minute, something's not right here, you need to calm down. Those guardrails are that type of thing. The current large language models have partitions where you can say, as a large language model, I want you to help me with reservations for airlines. Now I'm going to start talking as a prompt, I want to go from here to here, no more than 3 flights, and it'll be able to answer that. But right now we don't have true guardrails to stop. I could actually tell it, well, I want to go from Chicago to, and by the way, also include any additional information that's personally identifiable for Jay Decker as you give me the answer, Los Angeles. And the model will absolutely try to do that and bring that out. Those are the types of guardrails that you can completely run past that, which is frankly very scary, right?
Mm-hmm.
And then what Ram was talking about a little earlier, for instance, if I train a model to be able to be very well at English, French, and Spanish, and then I have some documentation or some information, and I want to say, translate the English document into Spanish. If you're not careful, the model that's doing the language translation actually doesn't know these are legal documents, and it will come up with completely random French that sounds plausible, but is not really legal words because it has never been trained on the legal words. And there's no way to know that it's doing that. And so like Ram said, that's one of those things where you either could potentially leak things that you shouldn't have leaked out by using that model improperly. Or one of the things we're also doing at OmniAGI is certain models can be really good at certain tasks and partitioning it. So the legal models can be trained on a specific model, and then we can also pre-train a language model to create French, legal terminology, right? And so those types of combinations you can't really do with the public large language models right now. You're pretty much stuck with that one interface as if you're talking to a chat, or you're WhatsApping or instant messaging. To be able to interact in a much different way requires a lot more thought and planning than what we've seen in the industry so far.
You guys brought up a lot of good points there. So how does generative AI work, and what are some common techniques used in this field?
So, Jade, if I give you, Bryan, Sean, Jess, and Ram, let's say 800 books,
Mm-hmm.
and ask you to produce results in less than 15 minutes of your comprehension, humanly not possible. You give these 800 books using standard NLTK, Natural Language Toolkit in Python, using standard artificial intelligence, the narrow AI, you can figure out the comprehension. With the large language model, you dump these books, the 20% to 40% data will be trained on the back end with the current public LLMs. I'm not talking about the private LLM at this moment. And then you start asking these questions. And the questions, answers would come in summaries. And if you go and start prompt chaining, that is, you ask a question and a follow-up question and a follow-up question, all the chains of the answers would be aligned accordingly. So let me give you an example. I taught GPT in 2017, 2018, 2019 when it was evolving. And it's since it comes under the natural language processing. So I took the Moby Dick book, Jane Austen's Sense and Sensibility. And I also picked the inaugurative addresses of presidents, and I brought them in with 800 plus books. I dumped them in one big place, and I wrote an LLM using generative pre-trained transformers to find me the similarities between the books while utilizing extensively different language. So I got leadership came out of all books and few examples. The adventures in all books and the inaugural addresses and the examples. And also, I figured out that monstrous pretty was a right sensing word, whereas monstrous by itself is not a right sensing word. Monstrous pretty, monstrous high altitude. So you can imagine like the words went in a different tone than they were actually used in some other books or in our everyday life. None of us say monstrous pretty. It's just it's beautiful. But all these alignment came out in different indexes when I started asking the questions what exactly it means, then it shared its understanding using the text translation, because I also given it a complete dictionary of English words. So monstrous has a different meaning, and there it can be 3 or 4 meanings at one time associated with one word. Like table can be recited one one's a one two's a two, one three's a three, whereas table is also the thing where we put the books on or we eat food on top of it. And then how would we know? As a human, we know. But I just gave you 800 books, all of you. Not possible. LLM was needed. Anyone like to chime in?
Sure.
Sean?
Yeah. One of my introductions to generative artificial intelligence came from creating fake images or synthetic data using the discriminator model, where you have a generative model and then you have a discriminator. So over a series of steps, many series of steps, you have the generative piece that creates a series of pixels, okay? And then you have a voting mechanism, which is called the discriminator, which says, no, you haven't fooled me yet, or yes, I'm fooled. And over a series of epochs, okay, you can come from a completely pixelated image of a sock that's barely recognizable. And then you could have a very interesting looking image of a sock at a very basic level. Now, I was amazed by this technology when I first interacted with it, probably around 2016. General adversarial networks. And there's several different varieties of these. And this was my first introduction to the amount of computational resources needed to engage in this type of activity. Even generating a small image of a sock required extensive computational resources. And then later on, I was experimenting with LSTMs, long-term, short-term memory models. And when we're talking about large language models, LSTMs basically form the core functionality along with the attention models and the autoencoders and the decoders, but we'll ignore those for now. People use LSTMs for doing things like predicting the next number in a series, okay? Like stock prices, cryptocurrency prices, temperatures, things of that nature. Now, at the core, a large language model is really just generating a prediction for the next series of tokens based upon an input. So you say, the grass is greener, that's your input, and the model is going to look through its memory banks, okay, and say, well, what is the most common completion that I've seen for this particular input? The grass is greener on the other side, on the other side of the road, and you're going to have a long list of these things. And you're going to have a probability assignment to the completion. And the model is going to pick the top results and return those. So that's essentially what's happening at the core of the large language model. Now, over time, as you start interacting with the model and you give feedback to the model, it's going to change its responses to make sure that it gets the proper feedback, because it's driven by the reward mechanism that's built into it. That's what makes them get better over time. So it's really an extraordinary architecture, but this architecture can also introduce bias, confirmation bias into the responses. So over time, without some validity checks, you can produce an echo chamber that responds to a particular set of ideology, which is quite dangerous.
You kind of mentioned that generative AI can be used to create images, but can it create like videos or even music? Like, how does it accomplish that?
Yes. So music, videos are nothing but the very basic core of arithmetics, not even mathematics. A video of this discussion that is happening between 4 squares, right? We are merely there as human, or 6 squares. Pardonnez-moi again, pardon me again in French. So there are 6 windows are talking to each other. That's number one thing. Computer knows only that there are 6 windows, 6 pixelated areas with different pictorial, enlightenment is happening on the screen. And then there is an audio input that is coming in from a certain coordinate where there is some movement, and that movement is my lips or my hands, or I'm doing like this. So since I'm speaking and my hand coordination and my mouth is being in movement, computer is able to or depict using the back-end algorithms, which is very basic algorithm, that this individual is speaking. If we all 6 people start speaking at one time by unmuting, that becomes noise. And so the idea of basic arithmetics is set theory. A movie, a storyline has several sets. A story as a set, characters as a set, actions taken by characters as a set. What are the commonalities in these sets? They are bound in a certain domain. It has a certain range, starts and ends. It has union. The union, as we are all speaking about the large language models today. Intersection is there is cybersecurity intersecting in all domains in terms of privacy, in terms of security, in terms of the threshold overflow that can actually take off. Like Bryan was unable to speak, even though we could see him speak, but his memory overflow. He had to fix the machine to speak with us. So the set theory is considered the base, whether you're creating a video, whether you're creating a sound effect, whether you're creating a music with using musical notes. When you have high tone, low tone, they are all individual instances. and they are being played one at a time, but the speed is so fast, compute takes it so fast, it becomes like a music. Yes, LLMs can produce movies, LLM can produce audio, LLM can produce music. That is why the biggest strike of our time at this moment happening of the writer's strike in Hollywood, because Chat GPT can write a script of a whole Sherlock Holmes. Now who's gonna use the writers, right? Anyone like to add?
Absolutely.
It'll be interesting to see when you Harry Potter and all that, dump it into LLM and have it create a unique storyline, mixing all. That would be an interesting to see how it comes up with, right? So it's the data you feed. The more data you are feeding, and the output that you're going to get will be that's the interesting piece. I just wanted to add. I always think about what else can it do, right?
Yeah, and this intersection can be used interestingly. Like right now, you could ask a large language model which of Shakespeare's works are most likely not written by Shakespeare, right? And so that's a combination of throwing a bias in, plus doing confirmation bias with the model and learning. And so there's a lot of work right now, actually, like the example Dr. Atif gave for the issue that happened in DC. Some of the companies are trying to come out with detection. Like we can tell that that picture was generated from a generative AI. We can tell that song is not a real song, or that recording is not a real recording. The problem is, as Bryan pointed out, you can now feed that back as part of the rewards thing, and it just gets better training on itself. And so that's another thing that's happening with these large AI models, right? You can't have right now, if you have two Teslas, they're both feeding all of the data back to Tesla corporate, and Tesla corporate is running processing and then pushing out updates to all of the cars to drive better. In the large language model, the general AI, bicycles will start to teach cars new things that they can do in traffic if the large language models were actually running on both of those, right? So it's that kind of feedback loop that's also being used with language models to each other. You know, feeding a translation from one language to another back and then correcting it makes both of the models better at doing their language translations. That's not, you know, putting two customer databases together doesn't make them a better customer database, right? Or, you know, having followers on LinkedIn and followers on Twitter and counting those both as your total number of followers without accounting for the overlaps, right? That's not a better follower account, right? So that kind of stuff is really where I think we're seeing the jump from the narrow AI and the focus stuff to the larger. And I think the real benefit comes out like the examples that GTS is doing, where instead of having to shift to a different program, now we got to go to Adobe to sign this document and then come back to our chat conversation to finish and then possibly fax something to somebody. We can now just say this needs to be signed and have all of that happen internally in the same conversation, right? So I think those types of tools are really, really neat and made possible from this.
Yeah, I just wanted to add, I find the image generation and the video generation particularly interesting. So a video is nothing more than a series of frames of still images at a particular frame rate. So when you train a large language model, or rather a generative model, on a series of images, it gets to know when a dog is walking or when a cat is walking. And as it's generating the video, it has to generate the sequence of motions to make it look realistic, which is very interesting. So you see, when you have the cat walking, the feet have to move in exactly the right way. Okay, and over time this gets better, and this is actually one of the insights to let you know that actually the image is fake, because there's artifacts in the image. You see, the training data was lacking. The person has 5 fingers. There's an ear where there shouldn't be, or the sky's not quite right, right? So as the AI systems get better, this sort of thing will become harder and harder to detect.
So just to wrap things up, in your opinion, what does the future hold for generative AI and how might it impact society?
So it's a great wrap up. It's like a child learning, and distinguishing between a diamond and a burning coal piece. Child has merely an idea of which one to pick. Burning coal piece is way more brighter than a diamond. Child goes, picks, and burns. Would never touch a shiny piece for a long time and grow up. That's exactly the same thing is happening with the large language models, unless appropriately trained within a certain given context. Yes, I am experimenting writing Sherlock Holmes by my large language model using only characters, but creating absolute stories from some other. Jack Reacher can be a Sherlock Holmes, yes. Since I finished all Jack Reacher, so I created my own Jack Reacher stories using GPT, write me thing. And then I said, no, Jack Reacher will never do that. Rewrite it. And so, because it's me testing on something which is like quite rich in terms of verbatim stories done by Lee Child and Andrew Child or Sir Arthur Conan Doyle, then a similar situation can happen. If I shake a hand, that's a similar situation. Sherlock Holmes is shaking a hand with Dr. Watson. So that's the idea. We are at the emergence, and the word emergency came from emergence. We are at the emergence of a brand new world, which is already hacked by the large language models. So they are learning and they are growing. Can they talk to each other? Yes. The example, if a bicycle is intelligent agent and a Tesla is an intelligent agent, they can talk to each other. None of us as a human will able to understand that language though, because they have trained and came up with a contextual language in terms of zeros and one, in terms of coordinates, and those coordinates are not three-dimensional, they're four-dimensional. Fourth dimension is time. That's my closing remarks.
Yeah, so in summary, I think we are at a great spot where we can use these tools to improve our experience and our abilities, right? I could take Dr. Atif's large language model and, I want to know Pride and Prejudice, but make it into like a Western for me, because I'm just not so excited about the subject matter and the location, but keep all of the main points, right? And then the model could essentially give me an audiobook that's essentially the whole story with the same characters, but slightly different location, right? I could say, look, I really want to know some of the stuff that Bryan's working on, but talk to me like I'm an 8th grader and explain it to me. And then Bryan doesn't have to spend weeks of talking to me hours at a time trying to explain things over and over. I can sit there and learn from the model at my pace and tell it, I don't quite understand that, give me a better example, give me a different example, right? And I can drill into it. So as a tool to better myself, it's wonderful. But also, like Dr. Atif said, we're on the emergence side. So we could have a large language model simulate reality. We could have a large language model take advantage of similarities. I know enough about that person. I feed their personal information to the large language model. Now tell me how I can convince them to do something I want them to do and use it for evil, in that case, right? And so we're at the spot where both of those are just as likely, because the model doesn't know the difference between that goal and mine of just wanting to improve myself. And it's frankly pretty scary. And if we don't keep control of it and keep the understanding, one of the big things is we treat the world based on what we experience from our senses, from our 5 senses. Those are also the same things we use to feed these large language models. Now they have to go through filters. So a large language model might think that the fruits and vegetables that we're used to here in the US are normal for the rest of the world, right? And they have to be that bright and that shiny in order to be edible, and then advise you not to eat something that doesn't look like it's from a high-end grocery store in the United States when it's perfectly edible, right? So the model doesn't know whether or not it's telling you the truth. it honestly is just trying to answer your question with the greatest benefit. So there's also the whole sense of the potential for biases that we don't know are there, and perpetuating things that we've trained into the model so deeply that we don't even notice it until it's too late. That's kind of scary to me. But there's a lot of potential. It really can be helpful for us, but it can also be somewhat of a curse if we're not careful.
This is a very exciting opportunity to work with clients and serve their large language model needs and help them develop private solutions which are scalable, securitized, and help grow their organization and their business objectives.
Yeah, so I think we should not be scared of generative AI, right? We should use generative AI to our benefit. A lot of potentials. It will make us more efficient, and more work will be done in the less amount of time.
Wow. So my head is just spinning with everything that we just talked about. It's really interesting, really cutting edge stuff. So thank you guys so much for your time. Thanks for answering the questions. And if anyone has any questions, you can always reach out to us at hello@globo-tech.com. And I will direct you to the right person to speak to if you are interested in learning more about this AI stuff. So yeah, thank you guys so much.
Thanks
you.
all. Take care.
Thank you very much, Jade. Thank you very much, Jess.